Okay, so we're going to open up again at page 11, our little quadratics book, and now we're going to be doing quadratic formula. So, you probably have seen the quadratic formula song on the YouTube video that is under one of the notes pages on Canvas. So we have x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. So, the main reason why we would use this formula is if you are having a lot of trouble factoring, if it's not factorable, especially if you have irrational numbers like square root of 2 and imaginary numbers like I in it. So you use the quadratic formula to find the roots of this example right here. 3x squared minus 5x plus 2 equals 0. Now again, when you're finding the roots, you're setting f of x equal to 0. So first you're going to identify what a, b, and c are. So in this case, we do need to know all three letters. So a is 3, b is negative 5, and c is 2. So we'll plug it into the equation. So we have x equals negative 5 plus or minus the square root of parentheses negative 5 squared minus 4 times 3 times 2 all over 2 times 3. We multiply those out. The two negatives cancel. They become a 1. So you have 5 plus or minus, and then 5 times 5 is 25. 4 times 3 times 2 is 24, and all over 6. So you're going to subtract 25 minus 24, and you get the square root of 1. So you can reduce it into 5 plus or minus the square root of 1 all over 6. That's the same thing as say 5 plus or minus 1 over 6. And then if you add and subtract those two, you get x equals 1 and x equals 2/3. So in this case, you could have factored this one. Let's try some more examples. So using the quadratic formula to find these roots. So on the first one, we know that a equals 2, b equals 3, and c equals 1. So we're going to use the quadratic formula to find our roots, which in this case, this is another one you could actually factor pretty easily. So x equals negative 3 plus or minus the square root of 3 squared minus 4 times a, which is 2, times c, which is 1, all over 2 times 2. So from there, you have x equals negative 3 plus or minus 9 minus 8 all over 4. We add that up, you get negative 3 plus or minus square root of 1 over 4. That's the same thing as saying negative 3 plus 1 over 4 and negative 3 minus 1 over 4. And when you combine those, you get x equals negative 1/2 and x equals negative 1. So go ahead and pause the video and see if you can find the next one. This one will have something other than rational numbers only. Let me move these down a little bit. So we have A equals 1, B equals negative 6, and C equals 25. So we're going to plug it into the quadratic formula. You have x equals negative 6, which is a positive 6, plus or minus b squared, which is 36, minus 4 times a times c, and then all over 2a, which is just 2 times 1. So there you have x equals 6 plus or minus square root of 36 minus 100 all over 2. So from there, we have x equals 6 plus or minus square root of negative 64. The square root of negative 64 over 2. So again, we have a negative in the square root, so that's going to give us an I. So you have x equals 6 plus or minus 8i all over 2. So you could pull out of 2, factor it out to get rid of it. Okay, the 2's cancel to become a 1. So now you have x equals 3 plus or minus 4i. So you have x equals 3 plus 4i and x equals 3 minus 4i. So go ahead and pause the video, see if you could do the last one. Okay, so let's determine where A, B, and C are. So A is 3, B equals 1, and C equals negative 10. So let's go ahead and plug in the quadratic formula. So we have x equals negative b plus or minus the square root of b squared, which is 1, minus 4 times a, which is 3, times c, which is negative 10, all over 2 times 3. So now we have x equals negative 1 plus or minus square root of 1 plus 120 all over 6. X equals negative 1 plus or minus the square root of 121 is 11 all over 6. So now we have x equals negative 1 plus 11 over 6, and x equals negative 1 minus 11 over 6. If you solve these out, you get x equals 5 over 3, and x equals negative 2. And so that would be our two roots for this equation.